Hello everyone. Today we're going to be talking about objects. So, I have created tree.java right here. This is an object. I'm going to run you through the basics of it. The first thing that's important to notice, first off we have the tester here. This tester has a main method, but you'll notice there is no main method in our tree class. So, important things to note about an object here. So this is a tree object. Despite the fact that it says class here, this is an object. This right here might be peculiar. Blah blah. Peculiar. This is our constructor right here. So you'll notice everything else is public int, public void, public double. In fact, pretty much every method declaration you'll ever do in Java will be public data type, then your name, or perhaps public static data type, then name. Constructors are different. It is simply public, and then the name of your class, as you can see here, capital T tree, capital T tree. In this case, we're accepting in number of trees. So right here, you don't have to necessarily use this dot, but I highly, highly, highly recommend it, and so does Java itself here. It's like that's not really going to have an effect. So you want to use the this.numTrees, because as you can see here, it's actually highlighted to tell you the difference. This numTrees is this numTrees, which is the same as this one and that one. The way that we understand this is this.numTrees means the numTrees that is in this class here that we are currently typing in. This allows us to take in a value of the same name here. It doesn't have to be the same name. We can just type in like tree amount here and it would still work the same. This is just demonstrating the use of this dot. It is highly recommended. In this case, right here, we're not taking in any value for height, so height is just becoming a default value. We have getter methods and set methods. So the difference between those is a setter method is what you use to take in a new value and set that value to one of the variables we have in our object. Whereas get like returns out. You would use a get in order to just like pass back the value of whatever the heck it is to your main. Like if I wanted to know, if I type over here, like as you see right here, original.getHeight, I want to be able to print out the height. And actually you can see it down here working because I tried recording this before and had a bit of an issue with the recording, so I have to do it a second time. But it's going to be better this time than it was the first time, so I can focus on the details and not typing it out like I originally wanted to do. Anyway, oh yeah, also, the reason we're doing a tree is because hashtag TeamTrees is awesome, and the link to that will be in the description, although you've probably already heard of it. Anyway, back to the tree class. Or object. Well, it's a tree class, but it's also an object. Anyway, that's just semantics. So for every single variable, it has to have a getter and a setter. This allows us to manipulate them after its original creation. So right here, you'll see I do have a method inside of our object in order to actually print the number of trees. However, I did not make one for printing the height. That is because I wanted to demonstrate that you can do the same thing outside of it. Like if you haven't created the print statement, you can use .getHeight in order to get the same variable out. It's the same thing as numTrees right here. I'm just printing out this. However, so we can actually go, we can make these private. Fun fact. So now, because this is good for like data protection, so if we set these to private, then the only way that you could possibly get the height out would be original.getHeight. So you'd have to use this method, getHeight. Otherwise, height would be inaccessible to you no matter what. So that is why it is nice to have these. This allows, as you can see here, you see the current information. I'll run it a second time here, and you'll see everything's still there. Now we're going to get to the finite amount of that. That is not the word to use there, Isabella. We're going to get to the... We're just going to get to it later. Okay, so I want to add a simple method here, just to show you the act of creating a method to work inside of your objects. So we're going to go public void plant tree. What plant tree is going to do is it is just going to plant one singular tree. So it's going to be this dot num trees plus plus. Plus plus just means increment up by 1. If I did minus minus, that would reduce the amount of trees by 1. So now that I've created this, what I can do, so our method is plant tree. If I go over here after our original print statements, these two are these first two lines. The -1 for average height is again because we are not taking in any number for it. So whatever we type num trees as here, right here, this number, when we are declaring this, just like we would say a scanner, this, whatever number this is the number that comes in right here, which is what num trees up here gets set to. So I can change that around and you'll see it change. But first things first, let's go plant a single tree. We've named it original. So original dot plant tree. You'll see it autofill there. Basically, here, I'm going to remove this so that we can see. Before it was adding 5, so now we should expect num trees to say 0, and then we should expect it to say 1 here. Let's just check that working. Yes, num trees 1. Now, the reason that we type the dot here, original, that is because we've named up here, it is data type tree, name is original equals new data type, and then arguments. So, original being our name, dot, what the dot does is it then allows you to call the methods of our tree object. As you can see here, we have getHeight, getNumTrees. Some of these are just inherent for all objects, but you'll notice setHeight, setNumberOfTrees. You'll notice that all of the methods that we set up here are there, and some more actually. But every single one of these is in here. So that is what you do. The dot just signifies that, hey, I'm going to call a method that is a part of our tree object named original. So original dot, let's set num trees. And our autofill puts in number of trees. We're just going to go back to saying 5 here. So we should expect, since we planted a single tree here and 5 here, we should expect to see 6 trees and our height being set to 8.8 still. So let's check that out. Number of trees 5. Well, let's figure out why that's the case. Yes. Because this sets it, it overrides. If we want it to be 6, we actually have to increment after we set it to 5, because 5 is going to override no matter what it is, because it's not a plus equals, which we can go back and change. But first I want to show you the finite difference here. It's a bit of finesse to it, but now it's 6. So let's fix that weird coding problem, shall we? Let's make it so it doesn't just set it. Let's make it a plus equals. So, Set number of trees. Okay. How about we go, instead of just equals, we make it plus equals. That means it's going to add number of trees to whatever number already exists here. So, instead of this overriding down to 5, this should stay at 6. Voila. 6. Very small thing, but the small things make big differences in programming. So, now we'll explain the height thing here again. So, height, of course, by default, we have the default value. Then we can set whatever the heck height we want in here. I have it saying average height because it makes more sense to track the average height of all of your trees than to give one height value for no matter how many trees you have. That would be weird. So, we have the average height plus original.getHeight, which says, hey, object, I need you to tell me what your height value is. So that's going to, let's just run through the logic of a single line of this and tab through the pages so you can see the code in your brain. So it's going to print average height plus, and then when this pops up, what it's going to do is instead of doing this, it jumps over here and it is going to run get height. So this line of code exists right there. That is what this is signifying. Hopefully that visual makes it make more sense. Just the same as when we have original.plantTree. It goes into the specific object of this tree, named original, and it accesses its method, which is, in this case, the plantTree method right here. So this code exists right here. Now, of course, we could have two instances of the same object, actually. So we can have another tree named second tree. This can equal a new tree, new space tree. And you know what? This new tree already has 6. We've already planted 6 trees on the second tree. So let's just go all the way down here. System.out.println tree object number 2. And we're going to go second tree dot print number of trees. Let's just see how that goes. And very darn well, just as well as it should. Number of trees, 6, the same amount we gave it. And we can even go, we can even type right here, second tree dot plant tree, and then it will show up as 7. As you can see, the same, and you know what, here, just to prove my point, let's get the number of trees from the original and print that right after this. So we'll compare it just so I can prove that the data for these two stay completely separate. So now you'll see tree number 2, number of trees 7, tree number of 1, number of trees 6. They each have an instance of all of this code. All of this, there is one set of this for tree 1, one set of it for tree 2. So they both have a different number of trees value, but they're both running off the same code base, if that makes sense. And as you can see it here, that's clearly the case. So effectively, you don't have to worry about how many instances of an object you have. Unless, this is a big unless here, and I'll cover that in another video, if you are using static. If your object is static. So instead if like this is public static, and this is public static. Effectively, everything in your object ends up needing to be public static, but if it is a public static object, there are a couple things that you need to be aware of that I'm just going to inform you of right here, and we'll do another video showing it off. You don't need to create your object if it's static. If the object is static, you don't need to generate it. And in fact, when it is static, this would not work. Static objects share the same data, the same variables here, in everything. So you can't actually do this if it is a static object. Every single reference to the static object is the same object. You cannot create multiple instances of a static object. If it is not static, you can have as many different ones as you want, as you can see here. So that is something to be aware of, and I'll make a video in the future explaining that. Now, inevitably, you're going to have some questions about this probably, because it is a little confusing. So put the comments down below on what you're confused about, and next time we talk objects, I can further clarify, and I'll also try and clarify in the comments below if I am able to in just a comment. So the link to the team tree stuff, that'll be in the description, and Isabella Electrum signing out.